In this project, we'll explore a NOT gate circuit. First, the power supply delivers positive 5 volts or positive 3.3 volts to the circuit. We use an LED which emits light when current passes through it, indicating signal or power presence. To protect the LED, a current limiting resistor is connected to its anode and the positive terminal. Next, an NPN transistor inverts the input signal, pulling the output low when the input is high, and vice versa. We also have a voltage dividing resistor that lowers the input voltage for other components. The push button connects to the transistor's collector, controlling the output based on its state. A push button is a momentary switch that completes or interrupts the circuit when pressed. Jumper wires connect components. The emitter links to the negative terminal, while the cathode connects to the negative supply. 2 wires also connect the LED resistor to the transistor, allowing current flow. And the one side of the push button connects to the positive terminal. Finally, plug in the cable and press the button. This completes the circuit, activating the NPN transistor and lighting the LED. When you release the button, the circuit breaks, turning off the LED.
Firstly, we put power supply module on the breadboard, then we continued with LED and resistor R2. After resistor, we connected transistors Q1, Q2 and Q3 with sequence. To turn on the LED, current must pass through the resistor R2, and it must happen when we push both buttons. So we connected both buttons and jumper wires carefully. As a result, when we press one of the buttons, LED doesn't light up because current flows towards resistor R1 and cannot pass through the transistor Q1. However, if we press both buttons together, the current will flow through both resistors R2 and R4. With this way, resistor R2 provides enough voltage to activate the transistor Q1, and it creates closed circuit which allows the current to flow through the LED.
We start with placing the LED. It's going to indicate the output of the OR gate. Next up, we're going to be placing our 330 ohm resistor. It limits the current through the LED and prevents it from burning out. Now we're going to be placing our transistors. The one near the LED is the output transistor. It controls the current flowing through the LED, and the other ones are responsible for controlling the basis of the Q1, which is the output transistor. Next up, we're going to be placing other resistors. They're both rated for 2000 ohms. They limit the current to the bases of the Q2 and 3, ensuring that the transistors are not damaged by excessive current. Now we're placing our switches. They are the inputs to the OR gate. Now we ensure that the jumper wires are placed properly. So what do the jumper wires do? They connect components that are placed at different locations on the breadboard. They establish connection between the power rails, whether it be positive and ground. And they form electrical connection between different parts of the circuit. Obviously, we make sure that they're placed in correct columns and rows. Once everything is done, we plug in our power supply. Now we test the system. We click on one switch, it works. We click on both at the same time, it works as well.